And so you'll see that we have y equals sine x. So the first thing we want to do is to think about and recall the unit circle. And then we want to think about what happens when we go around the circle one time and start going around it again. Okay, so we're going to talk about the reference angles. So the first thing that we want to put in our unit circle is, or in our X and Y table, and we really don't want to call those X and Y because since we're going to do the unit circle, the thing on the X-axis is going to be radians. So we're going to call this the radian Y table. Okay? So let's call this the radian Y table. So as we think about the radians, isn't it true? Thank you. As we think about the radians, isn't it true that we start in standard position at 0 degrees? Right? So, if you're thinking about sine, and you know from the unit circle that sine is the second value in the ordered pair, so the sine of 0 is 0, right? Okay, and then we have on our unit circle, let's do the 45, and we're going to do the 45 because when we graph things, we want our intervals to be equal, and 30, then 45, then 60, 0, 30, 45, 60, those are not equal intervals, are they? So you notice on this that I'm going to skip the 30 and the 60. You could put them on there, but you're going to have to change the way you label your x-axis. So this is going to be x over 4, or pi over 4. This one's going to be pi over 2. So as I count around the unit circle, I'm going to start at 0. I'm going to hit this orange one here, the 45, which is pi over 4, and then I'm going to hit the quadrangle, the 90-degree angle. So those intervals are 45-degree angles, aren't they? And I'm going to count those all the way through. And so the next one, if you think about the unit circle, is 3 pi over 4. And I could keep going around the unit circle. The next one would be pi. So continuing there, that would be pi. And then it would be 5 pi over 4. And let's just go ahead and see what the sine would be. Sine of the x value. Okay, and so we wanted this to be in radians. So the sine for this one is 0. The sine for this one is square root of 2 over 2. Well, what value is that? What is the square root of 2 over 2 so I can graph it? Pick up your calculator and change that to a decimal so you can get an idea of where you want to put that dot. What is the square root of 2 over 2? Nobody? What is the square root of 2 over 2? 0.707 something, right? So that's approximately equal to 0.707. So that's almost 3/4 of a block, if I'm thinking that way, right? Pi over 2 would be 1. Looking at this right here, sine is the second component here. And 3 pi over 4 is going to be, again, the square root of 2 over 2. And then this one is going to be 0. And then what happens is this one turns out to be negative square root of 2 over 2. So it starts to go down. Okay? So let's set up our graph. for the graph, I'm going to count pi over 4. And I let 2 of my blocks be 45 degrees. So this one then should be 90. Oops, pi over 4. That one should be pi over 2. And then this one should be pi over 3 pi over 4. And this one should be pi. So 2 more then is going to be 5 pi over 4. Okay? So let's begin to plot these points. The first one is here at 0, 0. Oh, I want to count all the way up to here and let this be 1. And so this be -1. Now you can let your interval be anything you want to, but I picked that on purpose because I know what the range for sine is. The range is what x is allowed to be. So again, this is 0, 0. This one is pi over 4 and 0.7. So that's going to be right in there. Okay? The next one is pi over 2 and up to 1. And then the next one is 3 pi over 4. And what happens here, it starts to go back down. Okay? And then I get 0 for this one. And then what happens here is it starts to go down below 0. So here is my curve. This is a curve, and this is called the sine curve. Have you guys seen this before at all? So what is going to happen over here where my graph is ending? What is that graph going to continue to do? It's going to go back up, and then when it gets to 1, it's going to turn and go back down. This is called a periodic graph because it continues to oscillate from 1 to -1, and then it's going to turn and go back up to 1 and down to -1. And up to 1 and down to -1. And so since this is going to continue to oscillate in that manner, we call it periodic. Okay? So what do you think is going to happen on the left side here? So in other words, if I'm looking at a table, I want to know what negative pi over 4 will be, and I want to know what negative pi over 2 will be, and I want to know what negative 3 pi over 4 will be. So let's go ahead and think about those on the unit circle. Negative pi over 4 is down to here. What is the y value when we go down to here on the unit circle? It isn't negative square root of 2 over 2? Because it has the same output as 7 pi over 4 on the unit circle, because in standard position, we're going down. So in that unit circle, right, we're now going down 45 degrees. So that's the same as 7 pi over 4, right? So that's negative. This one turns out to be right here, so that's 0. And this one, negative 3 pi over 4, turns out to be in this quadrant. So that, again, is going to be negative square root of 2 over 2. Right? And we decided that that was 0.7. So if we continue to graph these, this one goes to here. And then this one is negative pi over 2. Look at my intervals. You see they're the same. Okay? So negative 1 is going to be where I top out. And then I'm going to start going back towards 0. And I'm going to reach 0 here at negative pi, right? And then for this one, it's going to start going back up. So the sine graph is actually called a sine wave, right? A sine wave. So looking at the graph, you should be able to see that the domain is all real numbers because we can go from negative infinity to positive infinity, and all of the values for the input are defined. And for the range, you notice that it starts, the lowest value that we're ever going to have is here. This one continues down to here. And so the domain is negative 1 to 1. And it includes those values. So there's your interval notation for the range. The range of sine is negative 1 to 1 for the parent graph that we're looking at. This is called the parent graph because it has nothing in front of sine and nothing is multiplied by the x. This is the basic graph. This is like y equals x in a linear equation. Okay, so we have now looked at the sine graph, and you know that this goes on forever, and this is going to now go on forever, but it's going to continue to oscillate up and down. Because as we go around this circle, we get all the way up to 360 degrees, it's going to start repeating the answers, isn't it? Okay? So all of the values in the y are always going to be between negative 1 and 1. And the curve just keeps going like that. Okay? Sine graph.